What is up? Promise to get you a 5.5. Let's go get it. Integration by substitution. I'm not going to give you a bunch of explanations, just how to kind of solve these types of problems. U subs are basically the chain rule in reverse. Remember this? Something about leave the interior alone, take a derivative on afterwards. But we're going to say that u is some function of x. I know it's weird. I'm not going to get into a great deal. That was about to start going off. But come on, let's just see an example. And I love this example. I use this one a lot. So let's just see something. Let's start here. Let's say the y is equal to 1/2 sine squared of x. Let's do 1/2 sine squared of x. Now let's take its derivative. Not its antiderivative. Let's just take its derivative. And whatever answer we get, we're going to go back the other way and we'll see how it works. So we can say that dy dx, the derivative on this is, since this is a chain, right? That 2 is going to fall to the front. So we're going to get 1/2 times 2. And then we leave that interior alone, which is sine of x. And then we have to multiply by, right, because it's raised to the first, times its derivative, cosine of x. The derivative of 1/2 sine squared of x is just equal to sine of x cosine of x. Sine x cosine x. Cool. Cool. Didn't we learn something about, like, what happens, do you think, if you take the integral of a derivative? Wouldn't you go back to where you started again? Maybe plus a constant or something like that. But so I'm claiming if you are to integrate this derivative, we should end up back up at the same spot, right? Cool. And we started with a chain. This is a chain, right? When we found this derivative, we had to do a chain. Cool. Chain in reverse. So now here comes our gang. We're gonna write in from here, right into there. So sine of x times cosine of x, and then we'll put in that little dx symbol. Parentheses not really needed there, it's implied, but I like to put it in nonetheless. Here is how it goes. We are trying to find a function and its derivative. We are looking at this, trying to find a function and its derivative. Find a function and its derivative, and we're going to call it u. So there's no wrong choice here. I'm looking and thinking, you know what, right here, let's take sine of x, and I'm going to call that u. So u is equal to sine of x. Now here's the step, and I'm only going to show this the first time. When we take a derivative on u, we're going to write du dx. Typically I wouldn't write this. Now what's the derivative on sine? Cosine. And now it's like we're going to multiply this little dx over to the other side. After this we'll just write it. We'll say du is equal to cosine of x dx, because we multiplied this dx to both sides. It's kind of hard to even say that. So what we have here is a substitution. We have to be able, we're trying to create something that's simple, that we can actually find the antiderivative of. I don't have some sort of special tactic to just be able to look at sine of x, cosine of x, and going, oh, clearly that's going to be. No, there's no tactic. Like with antiderivatives, we have to create it and make it into something like that. So instead of writing in sine, so let's go back through. So instead of writing in sine, let's write in u, because u equals sine. So we'll put in u. Now we look over and see what matches. We want to get rid of this with respect to x bullshit, and we have to get rid of this cosine of x. So we're trying to get all the x's to go away so we can call it all in terms of u. Well, look at this. We have cosine of x dx right here. We can just replace it in with the differential of u. Now we're taking antiderivative of just u. The antiderivative of just u, oh come on, we know this. It's going to be 1/2 u squared plus c. All right, we're going to add 1 to that exponent, then divide by that number. Right. That's what we do in there. So we get 1/2, but oh shit, we didn't start in terms of u. We started in terms of x. We got to back sub that shit right back on in there. And now we can say we get to 1/2 sine squared of x plus c. 1/2 sine squared of x. It just happened that this plus c was plus 0. This one we just didn't know. It's the chain rule in reverse. Now we could have done this in a different way, and it could have looked very different. You could have chose cosine to be your u. Don't do that. Choose sine. Let's try another problem. Let's try and catch our pattern. Oh, here's an old, I forgot. This is the classic one. We got to do this. X squared plus, or x over x squared plus 1. This is the classic. So once you're into the problems, you're going, all right, I'm trying to find a function and its derivative. That's what we're doing. Function, derivative. So places you typically want to look for the function will be in denominators and underneath roots, or in logarithms, or trapped inside of functions. Now when I look at this, I know that the derivative of x squared is equal to 2x. That's good enough for us. As long as we can find something that's going to have the same power. So you got to see it a few times, and this won't make sense right at first. It's tricky, and it's a kind of a complicated game. So we're going to call, let's let u equal x squared plus 1. You always want to bring those constants along. Let's stop for a second. Bring constants. Bring those c's. Bring the numbers over. Because what happens when you take a derivative on plus 1? When you take a derivative on plus 1, you're going to get nothing. So we say that du over dx, but we're not going to write it that way. We'll just say 2x. Derivative of 1 goes away, and now we just write our dx at the end. So you always end up with a du on one side, and then something with a dx on the other. So I brought the constant. Now let's look. Now this is bad form. I'd like to just show you. So for just a moment, I'm going to replace that x squared plus 1 with a u. And then what's left over? We have an x and a dx. Again, don't ever do this. Don't ever do this. I'm showing you this. It is never allowed to have an x and a u in the same frickin' equation. We do all the substitutions off to the side. I'm just trying to show you for the moment. This is not allowed. Again, not allowed. Exclamation points. Don't ever do this. I will mark your ass down. Even though I'm showing you this, it's just so you can see. So we go back to here and we want to make this x dx. See this x dx? That's all up top. We want it to match, so we divide out the 2. So we get 1/2 du is equal to x dx. We just divided out the 2 and brought it to the other side. So we can make it match. Now that we see it, so I'm going to now go back. That x dx matches with this, so we can replace our dx with a du, and then we also have our 1/2. So I'm going to now remove that shit, because you're not allowed to have u's and x's in the same thing. This bullshit off on the right-hand side is called side work. Everything over here is side work. That's not part of the problem. You can set u's and x's all equal to each other. In your integral, we're only allowed to have x's or only allowed to have u's. So once we pop it in, we're like, well, we can replace that x dx with that 1/2. That 1/2 du. And you always put the du on the outside. Oh man, look at that 1/2. That thing sucks. It's all replaced. We can find the antiderivative of this, especially if you yank the dang constant to the outside, and just get left with 1/2 the integral of 1 over u du.
Well, shoot, that's that one case where the u's exponent is -1. So when you add 1 to it, you get a 0. So that has to be...
Oh, that's that natural log one. We know this. This is going to be equal to 1/2 times the natural log of the absolute value of u plus c. But we didn't start in terms of u. We started in terms of x's. So we need to take this u and replace it with what it equals, the x squared plus 1. Now, since x squared plus 1 is always positive, I do not need that absolute value. So I will remove it. It might be in your best interest to always leave that sucker there, because it's not necessarily wrong, but sometimes it's redundant. And that's how we do a little bit of u subs. Those are the basics. You got to get a lot of practice to be able to see all the frickin' patterns, because there's a ton of patterns. Do this homework. While I'm not going to take you to like a level 10 with this, a level 5 is hard enough. Get your practice.